Good evening, guys. This is Ganesh, and today we will be discussing on one of the sessions around Azure Firewall, which is an firewall service in Azure, along with one of their traditional and native services called as Network Security Group. So the entire session will be based on, well, the entire session's discussion will be based on Azure Firewall and its different components. I have a presentation which will outline the different features and what exactly Azure Firewall is and how that can be implemented if you are deploying this Azure Firewall in a production environment. So I'll just quickly open up my presentation and let's go through the agenda. So agenda is pretty narrow today. We'll be talking about what is an Azure Firewall, and then we'll see what are the difference between Network Security Group and Azure Firewall. And I had intentionally added this point so that people would understand, or people would be able to make decision whether they should be going with Network Security Group or whether they should go with Azure Firewall. And then there's one more thing. So the building blocks of Azure Firewall, which I have not included here, but we will have the subsequent slides as well in our presentation. And finally, we will conclude with the demo, which will outline how this Azure Firewall can be set up from scratch. Okay, so let's get started with our first point of today's agenda, which is overview of Azure Firewall. So what is basically an Azure Firewall? So if you look at Azure Firewall, it's a full-blown firewall as a service from Microsoft. So the way Azure is offering different services in Azure, like backup as a service, wherein we are using Azure Recovery Services for, then disaster recovery as a service, then we have platform as a service, and so on. So this is also one of the full-blown firewall as a service from Microsoft. Okay, so this service will purely help customers to design the firewall solutions in Azure. Then the second very important point is it offer customers with stateful firewall service. Now we can have a good discussion on what is a stateful firewall versus what is a stateless firewall. And maybe I have a few of the points on stateful versus stateless in my next slides. Okay, so Azure Firewall is basically a stateful service which can be deployed in Azure to control the ingress and egress traffic. So that's what the primary job of a firewall is, to control ingress and egress traffic. Okay, so this firewall can be deployed in your Azure infrastructure to control your ingress egress traffic within Azure. The third one, again, which is very important, is Azure Firewall is a managed service, which means that you don't have to set up any underlying infrastructure for installing this firewall. Now, why I have added this point here, because there are other firewalls services in Azure as well. Like you can go for the network virtual appliances services, which are offered by this third party firewall vendors like Cisco, Barracuda, Checkpoint, Fortigo, etc. But to install their firewall in our Azure infrastructure, we have to deploy those virtual machines in high availability. So it adds an additional overhead in terms of pricing. But since Azure Firewall is completely a managed service, that means I'm talking about a PaaS service. Here, you don't have to really set up any underlying infrastructure, and everything is being taken care by Microsoft for you. The fourth very important point is Azure Firewall service acts at a layer 7. So let me correct something over here. So Azure Firewall service can act at layer 4 as well as at layer 7 of OSI model. Okay, so unlike Network Security Group operates at layer 4, but Azure Firewall service can act at layer 4 as well as at layer 7 of your OSI model, and it can be used for controlling the application layer traffic as well like HTTP and HTTPS traffic. So when we talk about the application layer, that means layer 5, layer 6, and layer 7. These are called as application layers. Okay, so you can basically use Azure Firewall to control your traffic at an application layer as well. And then the very last point, is Azure Firewall also offers threat intelligence feature. So what exactly this threat intelligence feature is, this is an built-in feature with Azure Firewall, which allows you to either allow or deny suspicious traffic coming from the blocked IPs or the IPs which are being recorded in Microsoft's threat intelligence engine. Okay, so if there are any blocked domains or blacklisted domains, or let's say there are some blacklisted IP address, and if Azure Firewall thinks that the traffic is coming from one of the IPs which is in their block list, then it will also block such traffic. So Azure Firewall offers this intelligence built in with the service, and it is up to us whether we want to use this intelligence or not. Okay, so this was all about Azure Firewall, guys. The points that are mentioned here are very important. First is Azure Firewall is a full-blown firewall as a service from Microsoft. It's a stateful firewall service. Then it's a managed service, no need of deploying any infrastructure for installing this firewall. Then it has this built-in mechanism of detecting the threats based on the threat intelligence engine offered from Microsoft, and it acts at layer 4 as well as at layer 7. Now, a quick differentiation between what is a network security group and what is an Azure firewall. So, and where should we use? So, if you look at the first point in the network security group, it has written that network security group, also known as NSG, is a layer 4 firewall service, okay, which means it can control the traffic based on 5 tuple rules. So we have this specific rule called as 5 tuple rule, which means the traffic will be controlled based on the source IP, source port, source protocol, and then the destination IP, destination port, and destination protocol. Okay, so let's say I want to allow a specific traffic from a specific IP address. Okay, so that's where I can specify the source IP address from which the traffic is getting initiated. Then I can also specify source port. If I don't know the source port, I can simply specify star or any. Then I can also specify the source protocol. That means whether I want to use TCP, whether my traffic is classified as UDP, and so on. And then the destination IP and destination port. So it's basically operates at layer 4, the transport layer, and it operates on basis of the 5 tuple rule. Whereas if you look at the Azure firewall, it's a layer 7, sorry, it's a layer 4 as well as layer 7 firewall service, which means it can control the traffic based on the 5 tuple rule, as well as it can control the traffic at the application layer as well. So the top 3 layers, the layer 5, layer 6, and layer 7. Then the second point is network security group is basically a stateless firewall service, which means that it can programmatically either allow or deny traffic based on the 5 tuple rule, and it doesn't have any built-in intelligence to inspect the packet. So when a traffic flows to a network security group or any Azure firewall or any firewall, basically there are packets. Okay, so network security group does not have that built-in intelligence to inspect the traffic, to validate the traffic. Okay, it will only see from where the traffic is coming. Is it allowed in my firewall rules? If yes, it will allow. Okay, but let's say there is some malicious IP address from which the traffic is frequently coming and getting denied at the NSG level. So NSG does not have that built-in intelligence to understand that, hey, something is wrong here because I'm getting frequent traffic from this specific IP address and it is not going through. That means something is wrong here. So that intelligence is not available in your network security group. Whereas Azure Firewall is a stateful firewall service which can inspect the entire packet, and based on the built-in intelligence, it can allow or deny traffic for the suspicious IPs, domains, etc. Okay, so Azure Firewall, it looks that Azure Firewall is much better than network security group, but again, we can have a nice debate on whether we should be using stateless firewalls or stateful firewalls for the cloud workloads. The most experts says that it is good performance wise to use stateless firewalls as compared to stateful firewalls. Okay, The third point in the differentiation is network security group is basically a regional service. So this is a very important point. Since network security group is a regional service, it cannot span across multiple regions. So what I mean by that is, let's say if I create a network security group for one of my regions in East US, okay, and if I want to use the same network security group for my infrastructure, which has been deployed in a different region, let's say West Europe, okay, I won't be able to span that specific service because it's a regional service. Whereas Azure Firewall is a service which can be deployed centrally in a subnet. Like NSG can be either applied at subnet and it can be applied at the network interface card as well. Wherein Azure Firewall is a service which only sits in a subnet. Okay. And then the beauty of Azure Firewall is it can span across multiple virtual networks which are in different region, providing customers the centralized management. So one of the pains that I have seen with customers is, let's say if a customer has multiple regions in Azure. So if you have set up your infrastructure, let's say in East US to West India, and it could be a West Europe. So they have to bring in the firewall service in this 3 different regions. If you're using network security group, that's absolutely fine. But if you have to go with the stateful firewall, you can deploy multiple firewalls in these 3 different regions to control ingress and egress traffic. But Azure Firewall can be a central hub for your all these 3 different regions, and it can act as a centralized management point for the traffic to traverse. So the way we can set up this Azure Firewall is, let's say you have 3 different regions. As I said, we have East US2, we have West Europe, and let's say we have West India. So I can place my Azure Firewall in my East US2 region, and I will allow my networks in West India and West Europe to traverse from my firewall, which is in East US2. So all the traffic which is originating from my East US2 network and my West India network will go via my Azure firewall, which is sitting in my East US2. So this way we can have a centralized management, and since Azure Firewall can scale across multiple regions, so we can use one single firewall across multiple regions. But again, since it's a stateful firewall, we might see some latency. So whenever you're designing any solutions around Azure Firewall, you have to be very careful when you're deploying Azure Firewall for multiple virtual networks, because that is something which has to be taken into consideration. And one of the last points that I can think of in Azure Firewall, it's Azure Firewall being a PaaS service, it can scale based on the traffic. So like in a traditional network virtual appliance, so if you want to go with the third-party firewalls like Barracuda or Checkpoint, what you have to do is you have to deploy multiple virtual machines for high availability. Okay, so if one of the virtual machine goes down, the other virtual machine on which your firewall service is running can take over. But in Azure Firewall, since it's a PaaS service, it can scale based on the traffic. Now, what I mean by that specific point is under the hood, when you deploy an Azure Firewall, it is deployed in a virtual machine. Okay, and that virtual machine is being managed by Microsoft. But looking at the traffic pattern, so if Microsoft or if the since this Azure Firewall service is deployed in a virtual machine scale set, there is an built-in rule that is applied. So Azure Firewall or Microsoft Azure keeps on monitoring the traffic, and if it thinks that the traffic is coming at a very highest higher what can say higher numbers, then it can probably create multiple instances of Azure Firewall, giving you an high availability as well as the scalability. Okay, so this is usually a basic difference between network security group and Azure Firewall. And as long as the pricing is concerned, as per my knowledge, network security groups are not charged, so it's free of cost service. Whereas Azure Firewall has 2 different components. One is a fixed cost, and other one is the total traffic which is received by Azure Firewall. So I can walk you through the pricing page wherein we can see this 2 different components. One is the fixed cost and one is the floating cost based on the based on the number of the size of the traffic that you receive on your Azure firewall. Okay, and out of this two, the first component is I would say a very costly component, because that's where the fixed cost comes in. So tentatively, if you see, it goes around 900 to 1,000 US dollars per month. So it's not that uh, cheaper as compared to the other uh, firewall service, which is NSG. So NSG is absolutely free of cost, but you cannot have more features in network security group. But Azure Firewall provides you a full-blown firewall service. So yes, it is costly. But if you compare Azure Firewall with the other network virtual appliances like Cisco, Barracuda, and Checkpoint, then Azure Firewall can help you save around 30 to 50% of your cost. So if you are planning to go for Barracuda or the other network virtual appliance service, then I would recommend that you go back and check Azure Firewall as well. Okay, let's move on to the next point. So before I get into the key concepts of Azure Firewall, guys, you can let me know if there are any questions on the first two slides that we have covered.
No questions, sir.
No question.
No questions, sir.
Okay, perfect.
Okay, a small question that you mentioned that it is a fast service, right? So let's suppose we deploy an Azure Firewall and we just need to bind 3 to 4 regions, different regions with that firewall, right? So I think the latency should be there, right? If we use the Azure Firewall for the 4 regions. So let's suppose there is a high load in the network and we need to scale in the more firewall. So it can be done automatically by Azure, or an administrator need to scale in the new firewall for it.
Okay, so since Azure Firewall is a PaaS service, it can scale automatically based on the traffic pattern. So there is no need of an administrator to manually scale up the instances.
Okay, so do we need to set the upper limit and the lower limit?
No, you don't have to do that because everything is controlled by Microsoft in Azure Firewall. So they are keeping an eye on it. So they very well know when there is a need of spinning up another instance of firewall.
Okay, and second question is related to the cost for that firewall. So currently, let's suppose I have configured just single firewall, Azure Firewall, and suddenly the load increases, and Microsoft had suddenly spin up 2 more firewall instances in the environment. So should we charge for only a single firewall instance or all the 3 at that time?
No, so the costing or the pricing that you get for your Azure Firewall also includes the scalability as well. So if $900 is something which Microsoft is charging you for your Azure Firewall service per month, then that also includes the scalable instances as well. So you will not be paying additional for your scaled instances.
Okay, so it is as per our, it is not related to the load. It is the fixed cost which we need to pay to Azure. Whether we will be, whether there is a need for extra firewall instance or not.
Yes.
Okay, thank you.
Okay. So moving on to the next slide. So if you want to deploy Azure Firewall, you have to understand the key concepts of Azure Firewall. So there are specific terminologies that are being used in Azure Firewall by Microsoft. So if you are well aware of this terminologies, then it will be easier for you to set up any Azure Firewall, and you can also configure these rules. Now, one of the advantages I see with Azure Firewall is anyone who has basic understanding of firewall can work with Azure Firewall. So you don't have to have that expert network guys or those expert firewall guys to set up rules in your Azure Firewall, like the other network virtual appliances you have in Azure, like Barracuda Firewall. It could be your Checkpoint, it could be your Fortigo, Cisco, etc. This requires a specific skill set, expertise to manage this firewall. But the advantage with Azure Firewall is anyone who has a basic understanding of firewall can work with the service, okay, can set up different rules based on the different business requirements. Okay, now let's get into what the key concepts of Azure Firewall are. So one of the key concepts of Azure Firewall is NAT rules. So NAT is basically a concept of network, which is also called as network address translation. This NAT is typically used for translating the traffic. Okay, now there are different types of NAT. I would encourage you guys to go ahead and Google for the NAT concept. So there are concepts like DNAT, SNAT, NATPAT. Okay, so these concepts are nothing but DNAT stands for your destination network address translation. SNAT stands for static network address translation, and then you have NATPAT as well. Okay, and every other NAT type is used for a different purpose altogether. So what Azure Firewall offers is one of them is NAT rules. So if you look at the point, NAT rules are typically used with the incoming traffic. So anything that you expect to come from internet to your firewall. Okay, this is called as incoming traffic. So anything that you expect from your internet to your firewall is called as incoming traffic. And when you want to translate any incoming traffic to a specific IP and port, this is called as destination network address translation. Okay, so if you have not understood the meaning of this sentence, I have given you an example. So imagine that you are an internet user. So you're sitting on your internet. Let's say you're sitting at your home and you have an Azure virtual machine, which is deployed in Azure. Okay, and that Azure virtual machine does not have any public IP address. So if you see here, you have created an Azure VM which does not have this public IP address. Okay, so if you don't have a public IP address associated to a virtual machine, you cannot access it over internet. Okay, so if you want to allow this virtual machine to access over internet, what we can basically do is we can create a DNAT rule in our Azure Firewall, which will translate the traffic coming from internet. Okay, which will translate the traffic coming from internet to the destination. Okay, so the destination here is our destination VM and the port. So this is what an DNAT rules are, or the NAT rules are basically. So you can also set up NAT rules for other purposes as well. It's not just related to your RDP, but let's say you have a virtual machine which is running Linux. Okay, so you can translate your incoming port to your SSH. Okay, so SSH is your port 22. So I have an example as well, which we will be practically deploying this in our labs so that you're well aware of this terminology. So this is one of the terminology called as NAT rules. Okay, so NAT rules are basically used for translating your incoming traffic in a nutshell. Now then you have network rules. Okay, so what are network rules? So network rules are used to allow denied traffic based on source IP, source port, destination IP, and destination port. This is very straightforward. So if you want to, let's say, deny port 445 in your network, okay, so you don't want your users to access SMB file shares and you want to block this port. So you can mention your source IP, can specify source port, and then you can also specify your destination IP and destination port. So if you have any such type of requirement, then network rules are the ones which you need to create. And then one of the very important points with the network rules are, so network rules are evaluated based on priority. Okay, the way we create rules in network security group with priority and what is the meaning of priority. So if you have a rule created with a lower priority, that means it has an higher importance. So all the rules with low priority are evaluated first by your Azure Firewall as well, as compared to a rule with highest priority, which is, so in Azure Firewall, 100 is higher. Okay, 100 is higher than 200. So lower the priority, higher the precedence. So if you have an rule which says rule with 100 priority says allow RDP, And then at the same time, you have a rule 200, which says deny RDP. So in this case, since the allow RDP has a lower priority, which says that this rule will have high precedence. That means the user will be allowed to RDP into the VM, and this rule will not be evaluated at all. Okay. So it's very similar to your network security group. So if you are well aware of what network security groups are and how it really works, then you should not face any problems in the Azure Firewall. And then the last one is application rule. As I said, Azure Firewall can operate at layer 7. So this firewall rule, so application rules, is very specific to your application layer, which is used to control your HTTP, HTTPS traffic, okay, for your application. And I have given an example here. Let's say you want to allow internet on the servers, okay, except few websites. Then you can achieve that using application rule. So imagine that you want to allow the internet on all your servers within the network, okay, but at the same time you want to block a specific, I would say, websites. Let's say I have a policy to block the social networking. I'm writing social engineering, sorry. So I want to block social networking sites. So this can be achieved using your application rule. So application rule supports what is called as FQDN. So you can block a traffic based on like star.facebook.com, or let's say star.twitter.com. So that is what called as FQDN. And then we also have something called as target FQDNs. We will see those concepts when we actually get into the demo. So these are three building blocks of Azure Firewall: NAT rules, network rules, and application rules. So NAT rules typically talk about translating your incoming traffic. Okay. Application rule really talks about outgoing traffic. And then your network rules are nothing but these are all your layer 4 rules. Like if you want to allow denied traffic based on source IP, source port, and destination IP and destination port. Okay. If you look at the network security group, in network security group, we can only have this network rules on which you can create a rule basically with a priority and specify source IP, source port, destination IP, and destination port. But if you talk about Azure Firewall, it offers you the NAT service. It also offers you the layer 7 layer 7 service to control application traffic as well. Any questions, guys, in this? So if you have understood the three concepts, even if you have not understood in detail, that's absolutely fine. Once we get into the demo, you'll get a clear picture of what these exact concepts are. Any questions, guys, over here?
No.
Okay, cool. So let's move on. Now, there is a specific rule processing logic, which we call as Azure Firewall rule processing logic. So when we talk about Azure Firewall, okay, the rules are processed in a specific order. Now, since we have three different building blocks, like you have NAT rules, you have network rules, and you have application rules. So which rules are evaluated first is nothing but the rule processing logic. So when you have configured network rule as well as application rule, then the network rules are processed first based on the priority before any application rule. So I have given an example here, example of rule processing logic. So you have created a network rule to allow internet for the VMs in your virtual network. Okay, so you have basically allowed internet in your entire network using a network rule. So this is your rule number 1. And at the same time, you have also created an application rule to deny google.com in your network. Okay, so in this example, what will be the end result? So in this example, what will happen? Since the network rule has allowed to access internet, and according to the processing order, network rules are evaluated first before your application rules are, Google will be allowed in your network. So your application rule will not have any importance in this specific example, okay? Because network rules are evaluated first before your application rules are evaluated, Okay, so this is one of the examples of rule processing. So whenever you're dealing with different rules in Azure Firewall, dealing in rules, you have to consider this rule processing logic. Okay, that network rules are evaluated first, and then your app rules are evaluated, application rules are evaluated. So I have a couple of examples as well, which we will see in our demo. So any questions here, guys, in the rule processing logic? Just like network security group. So in network security group, we have inbound security rule and we have outbound security rule. But in Azure Firewall, we don't have any such inbound and outbound. Whatever we have a network rule, and you have to control this traffic based on source IP, then source port, and destination IP and destination port. Questions, guys? I have a sample architecture of Azure Firewall. I can show you how this entire Azure Firewall can be set up. Okay, so let's move on. So this is the Azure Firewall sample architecture, which we will be also deploying in our infrastructure. So on the extreme left, so you have an on-premises network, okay, and then in the middle, so this is all about Azure. So you have hub virtual network and your spoke 1 and spoke 2 virtual network. I'll talk about this topology as well. So on the extreme left, we have on-premises network, and this on-premises network is connected with Azure, okay, using either site to site, okay, or it could be using express route. And then in this specific virtual network, there are 3 different subnets. Okay, you have an Azure Firewall subnet, then you have a gateway subnet, and then you have a management subnet. Okay, and in this management subnet, you have created a jump box. Okay, so here I'm typically talking about an hub and spoke architecture. What is a hub and spoke architecture? Wherein if users wants to access any resources within a network, they cannot directly access those network and they have to go via this jump box. And there are other examples as well, just not the jump box, but there is something called as shared services. So a lot of organizations, what they do is they deploy their shared services in their hub virtual network. Like one of the shared service could be your domain controller. Yeah, one of the other services could be, let's say, your SCCM servers and so on. So we can have shared services deployed in our management subnet, which this spoke can access. Okay, so right now we have this hub virtual network here, in which there are 3 different subnets. We have a management subnet in which I have created a virtual machine. Then we have a gateway subnet, which is responsible for establishing a connectivity with any on-premises or any other site. And then we have an Azure Firewall subnet. Now, if you want to deploy an Azure Firewall in your virtual network, then it requires a dedicated subnet with this name, Azure Firewall subnet. Okay, if you don't have a subnet with name Azure Firewall subnet, then you have to create the subnet first before you go ahead and create the Azure Firewall service. Okay, and that's why they have specified as Azure Firewall subnet over here. Now, if you look at on the extreme right, there are 2 different virtual networks. So this virtual network is called as Spoke 1 virtual network, and then the other virtual network is called as Spoke 2 virtual network. And these 2 virtual networks do not have connectivity between them. So they are not directly connected using VNet peering. But the way they are connected is, so your hub virtual network has a connectivity with your Spoke 1 virtual network, and as well as the hub virtual network has a connectivity with your Spoke 2 virtual network. But if you look at Spoke 1 and Spoke 2, they don't have any connectivity between them. So how will a traffic flow from Spoke 1 to Spoke 2? So if someone from Spoke 1 wants to access a server in Spoke 2, how the traffic would traverse? So here comes the beauty. Okay, so Azure Firewall can be considered as an centralized hub. Okay, so it can be considered as centralized hub. So what you can do is you can traverse. Okay, Okay, so we use this term called as traverse. You can traverse the traffic of spoke 1 via Azure Firewall, and then it will reach your spoke 2. So basically, what you can do is any traffic which is originating from spoke 1, what you're doing is you're redirecting that traffic to your Azure Firewall, wherein the traffic will get filtered based on the rules that we have set up, and then the traffic will also reach to your spoke virtual network. So over here. Now, the advantage of traversing the traffic from your Azure Firewall is, let's say you have a rule in firewall which does not allow Facebook to be opened. And here, one of the users is trying to open facebook.com. So if the traffic lands up on your Azure Firewall, the traffic will be evaluated. And since you have blocked facebook.com on your firewall, the user will not be allowed to access facebook.com. So if you are traversing everything from the Azure Firewall, that means rules will be evaluated over here. Okay, so no one can do anything on their own. So everything will be tracked, audited, and either allowed or denied based on the rules. So this is called as hub and spoke architecture, wherein the spokes don't have any connectivity between them. Now, you guys must be thinking, what exactly is the use case? Why we are not connecting these two virtual networks? So, so there are applications. There are specific applications which do not require connectivity, which do not require to have a connectivity. Okay, so in that case, what people do is people deploy them in their isolated virtual network. Okay, so let's say I have an application like SAP, which I don't think that it should require connectivity with other virtual machines in my network. So I can place those virtual machines in a different virtual network altogether. Okay, so if anyone wants to reach to that SAP virtual machines, then they have to go via this jump box, because that's how I have allowed traffic. So you can create a rule on Azure Firewall that if someone wants to RDP to this virtual machines in this network, it should go via the jump box only. If you have any other virtual machines in your management subnet, then if someone tries to access this virtual machines, they would get an access denied or their connection would drop. So these all rules can be controlled in your Azure Firewall using those network rules. Okay, so we will be setting up a very similar infrastructure to what I am showing you in front of you, in which we will create one hub virtual network. So I already have this set up, but the connectivity has not been established. So what I have done is I have established an hub virtual network in East US2. And then I have another virtual network, which we'll treat as a spoke virtual network in Southeast Asia, in Southeast Asia. And then I have another virtual network set up in West Europe. West Europe. What we have to do is we have to first establish a connectivity of our hub virtual network with spoke virtual network. So we will do that thing first. And then I also have a virtual machine which is sitting in a hub virtual a spoke 1 virtual network and spoke 2 virtual network. Okay. So the first thing is we have to establish this connectivity, and then we will start deploying our Azure Firewall. Or we could do the other way. Since Azure Firewall takes some time to deploy, what we can do is we will start the deployment of Azure Firewall first in our hub virtual network. So the virtual network which I have in East US2, we will treat that as a hub virtual network, and we will create an Azure Firewall subnet and start deploying Azure Firewall. And meanwhile, this Azure Firewall service is getting deployed, we will configure our rest of the things. And one more thing, guys, in order to force a traffic from your spoke 1 virtual network to your Azure Firewall, we will have to set up UDRs as well. So UDRs are nothing but your user defined routes. So with user defined routes, we can basically tell to which hop the traffic should be redirected. Okay, so we will deploy all of this live in our demo. So let's go ahead and start our preparation. Okay, so I'll just end this presentation and I'll go to my Azure portal. So this is my Azure portal. Let me just quickly give you what exactly we are trying to achieve. So I am currently in virtual machines, so I have to go to my virtual networks. And here I have multiple virtual networks, but we are only worried about 3 different virtual networks, which is so CT virtual network, the one which is in East US2. We are treating this virtual network as a hub. Okay. And then we have 2 different virtual networks called as CT VNet Asia and CT VNet Europe. So as I said in the presentation, that we have one virtual network in East US2, which we will treat as a hub virtual network. And then you have 2 spoke virtual networks. One is in Southeast Asia and the other one is in West Europe. Now, we have to deploy this Azure Firewall in this specific hub virtual network. And one of the prerequisites that I shared is you have to have a subnet with the name called as Azure Firewall subnet. So let's see if we have that subnet already created. If not, we will create one. So if you go to the subnets, so I already have this Azure Firewall subnet. In case if you don't have, it's very simple to create. Let me delete this and show you how you can create a subnet with the name called as Azure Firewall subnet. Okay. And once the subnet is created, we will start provisioning the Azure Firewall instance. So the subnet has been deleted. Let's go ahead and create a subnet here. So I'll click on add subnet and Azure Firewall subnet. So you should match the name with the subnet name. So you have Azure Firewall subnet and we have specified Azure Firewall subnet. And you have to specify an address range to your Azure Firewall subnet. I'll go with the defaults at the moment and click on OK. Once this Azure Firewall subnet is created, okay, now you can see Azure Firewall subnet is created. We can go ahead and start deploying our firewall instance. So I'll go to search and type in firewall, and you can see here we have this service called as firewalls. I can click on the firewalls and it says currently we don't have any firewalls to display. So let's click on add and start deploying our firewall instance. So here you have to pick your resource group. So in my case, I'm selecting a resource group called as ARM test. And here I am providing the name of my firewall. CT prod AZ firewall. So this is the name that I'm providing to my Azure firewall. And it is asking us in which region you would like to deploy this firewall. So since we have to deploy this firewall for our hub virtual network, which is in East US2, I'll go ahead and pick my region over here, which is East US2. Then if you want this firewall to be highly available across the zones, it also supports zone resiliency as well. Okay, so if you want to deploy this firewall in multiple zones, you can pick those multiple zones here. But right now, I'll go without availability zones. Then it is asking us, since firewall service, since Azure Firewall sits within a virtual network, you have to select the virtual network name. Okay, so here you can see virtual network name. It is asking you to create a virtual network, but we don't want to create any new virtual network because we already have one in place. So I'll select use existing. So when you click on use existing, you have to select the virtual network from the drop down. So these virtual networks are the ones which are created in East US2. So I want to select CT VNet, which is my hub virtual network, and what it says. Azure Firewall cannot be used with a virtual network from a different resource group. Now I have intentionally selected this different resource group for the demonstration. So what it means that the resource group in which this VNet is created, the firewall also should sit in the same resource group. So here you can see this CT VNet has been created in a resource group called as Cloud Travelers-RG. And here I am selecting ARM test resource group for deploying this firewall, which is not allowed. So I'll go here and change this to Cloud Travelers-RG. And you should see this error going now. So yes, I have selected the CT VNet now. Now, since Azure Firewall has to have an public IP address, because any traffic which is coming from the internet will use the public endpoint of your firewall, you have to create one firewall IP address. Okay, if you have any firewall, let's say free IP address, free public IP address, you can associate that. But in case if you want to create a new public IP address, you can click on add new. So in my case, I already have one IP address, one public IP address, which is not associated to any resource. So I'll select this CT firewall PIP, and then I'll click on review and create. And then here, this is a summary of the selections that we have done. So I'll click on create. So we are trying to deploy an Azure firewall in a virtual network called as CTVNet. So let's try to correlate with this architecture diagram. So you have this hub virtual network called as CTVNet, in which we have created a subnet called as Azure Firewall subnet, and we are creating that Azure Firewall inside of this subnet. So let's click on create, and this will start the creation of Azure Firewall, which takes around 10-15 minutes. And meanwhile, this firewall is getting deployed, we can complete our rest of the networking pieces. That is very important. Okay. So what I'll do is I'll go to my CTVNet. So I'll navigate to my virtual networks and go to my CTVNet. So since CTVNet is my hub and VNet Asia and VNet Europe are my spokes, I have to create a connectivity between CTVNet and VNet Asia and CTVNet and CTVNet Europe. Okay. These two will not have any connectivity between them because we want the traffic to traverse from the firewall. So I'll go to CTVNet and come to the peering section of that VNet. And right now you can see we don't have any peering set with this specific virtual networks. So I'll click on add. Here, what you have to do is you have to provide a name to your peering. So what I usually do is I usually select the virtual network with which I need to peer this VNet. So let's first peer this CT VNet with CT VNet Asia. And I can then just copy this name and paste it over here. But instead of copying this, let's have some meaningful name. I would say hub VNet to let's say hub VNet to Asia VNet. I would say Asia VNet. Now we know that Asia VNet is a spoke. So I have named it this peering as hub VNet to Asia VNet. And I have selected the virtual network with which I want to peer this. Now let's copy this and paste it here. So you have to create a two-way connection. So now this connection would be automatically created from your spoke VNet to your hub VNet. So here, what I'll do is I'll remove this and I'll paste it here. And then I'll remove this too as well. So Asia VNet to hub VNet. So you have to basically create a two-way connectivity between your virtual networks. And I will ensure that the virtual network access is enabled from your hub VNet to your spoke VNet, and as well as from your spoke VNet to your hub VNet. So this is enabled already. Let's click on OK. And then what we will do next is we will create a peering with our European VNet. Okay, so I'll click on add. I'll select the virtual network, the European virtual network, and then I'll provide the same name. So hub VNet to Europe VNet. And then here I would say Europe VNet to hub VNet. Hub VNet. OK. And now let's click on OK. Now it will start creating a peering between CT VNet and CT VNet Asia and CT VNet Europe. So let me correlate this on the architecture diagram. So what we have done right now is we have paired our hub virtual network with our spoke virtual networks. So this is our virtual network, which is in East US called as CTVNet. And we have paired this virtual network with one which is in Southeast Asia called as CTVNet Southeast Asia, and one which is in Europe called as CTVNet Europe. So you can see here CTVNet Europe, CTVNet Asia. Now there's two. So the pairing has been created between these virtual networks. I have virtual machines created in this. So I already have a CTDC1. So I have one more subnet in my hub virtual network called as a DC, okay, in which I have created a virtual machine called as CTDC1. So you can treat my subnet as management subnet and the virtual machine as CTDC1. So I'm powering on this virtual machine. And then in this specific virtual networks, I have this virtual networks. So in the spoke VNets, I have one virtual machine each to test the connectivity. So these are the virtual machine. So you have VM Southeast Asia and we have West Europe. So I'll power on this virtual machine as well. So what we have to basically test is, so from this specific virtual machine, we have to test whether we are able to reach this virtual machine. If we are able to reach this virtual machine, that means that this connectivity has been established, but we should not be able to reach from this VNet to this VNet directly. Okay. So I'm just waiting for this virtual machine to come online. And there you go. This virtual machines are now showing up as up and running. So I'll first try to connect Southeast Asia virtual machine. But if you have realized, you can see you don't have any public IP address to this virtual machine. So I cannot ideally connect to this virtual machine from my internet. To connect to a virtual machine from the internet, you should have a public IP address. And this has been done intentionally to show the demonstration. So if you go to the West Europe virtual machine, even this does not have an public IP address. So basically, I have restricted access to this virtual machine only via a private IP address, and no one should be able to get through this virtual machine via a public IP address. So the only option which left with us is to go via our jump box. Okay. So the only option to reach this virtual machines which are in spoke VNets is to go via this jump box. So what I can do is I can connect to this virtual machine. We have considered this virtual machine as a jump box. So I'll log into this virtual machine using my local credentials, and then we will test the connectivity. So I'm trying to connect to my virtual machine here. And once the virtual machine comes online, we will try to ping the private IP addresses of this virtual machines. Okay. So let's try to copy the private IP address. So if you go to Southeast Asia, you can see the private IP address of this virtual machine here. So I can copy this and go to that jump host, which we're treating it as a jump host. And we'll try to ping this via command prompt. So I'll open a command prompt or PowerShell, any shell which you like. Sorry for the virtual machine's performance, since this virtual machine is running a lot of different services related to Active Directory. It sometimes lags a lot. Okay, so I'll open my command prompt here. And then I'll try to ping the private IP address of that virtual machine. And you can see I'm able to reach my Southeast Asia VM from my hub. Okay, so let's test for the West Europe as well. I'll copy this. And then I'll try to ping that as well. Ping. No. Okay. Ping 172.1631.4. All right. So we are able to reach our virtual machines from our hub jump box. Now it's time to connect or to forcefully route the traffic of our spoke virtual machines via this Azure Firewall. Okay, so how it can be achieved? It can be achieved via creating an UDR. So what is an UDR? So UDR is like a route table where we can explicitly specify the routes. So let's see if the firewall has been deployed. And the good news is the firewall has also been deployed. So let's first go to our firewall and see what exactly it looks like. So if you go to the firewall, we have this firewall created called as CT prod AZ firewall. It has been created in a resource group called as Cloud Travelers-RG. So if you open this, if you click on that firewall, the overview will provide a good amount of information in which resource group it is, in which location it has been created, and so on. But I am currently interested in two different things. One is the firewall's internal IP address, which is called as private IP address, and the firewall's public IP address. So this was the public IP address we have associated. So if you click on this firewall public IP address, you should see what exactly the IP address is for your firewall. So this public IP of your firewall will be used when any traffic which is coming from internet wants to be either allowed or denied. Okay, so let me open a duplicate tab so that I can multitask. Now, the thing that I would like to create is called as route table, okay, which is also called as UDR. So if you type in UDR, it will point you to the route tables only. So I'll click on route tables, and it currently says that you do not have any route tables in place. So we'll click on add. And now what we are trying to achieve is we want to route the traffic from Spoke 1 virtual network via our Azure Firewall. So basically, if a traffic is originating from this virtual machine, it should redirect that traffic to your Azure Firewall. So the way that can be achieved is we will first create what is called as UDR. So I'm creating this UDR for my Southeast Asia VM. So I'll select the resource group from the Southeast Asia, which is Cloud Travelers Asia, and the region in which you would like to create this UDR. So no, this virtual network is in Southeast Asia. So I have to select the right region. And here I would say something like route table Southeast Asia, or let's take it Asia. And there's nothing much to be configured while you're creating the route table. So I'll click on review and create, and let this UDR gets created. Okay. So we have created a UDR for this specific region. We haven't configured anything yet, but let's parallelly create a UDR for our West Europe VNet as well. Okay. So I'll go back to my UDR again and create a new user defined route. So here I will select a different resource group from the Europe region, which is Cloud Travelers Europe. And that VNet has been created in West Europe. So I'll select West Europe as my region. And then I would name this as route table -Europe. And I'll hit review and create. And finally, I'll click on create. So let's wait for this route tables to finish the deployment. Once it is done, we will configure this route tables. So when we are talking about route tables, there are two things that you have to basically configure. Okay. One is the routing rules, and then we have to associate this route table with a specific subnet. Okay. So we will go to your route table now, and we should be able to see two different route tables here in a moment. Okay. So we have created one route table for our virtual network, which is in Asia, and we have created another route table, which is in Europe. So let's configure the route table for Asia. So I'll click on this route table, and then you have something called as routes, and then you have subnets. Okay. So we will create a route first. So if you go to routes, you have to click on add, and here I am creating a route now. So this is basically a route name, what you're trying to create. So I would say Spoke VNet to Azure Firewall. Okay. It could be anything, guys, but I usually love to provide some meaningful name so that in case of troubleshooting, I should be very well aware of the things that I have configured. Okay, so I'm naming this rule as Spoke VNet to Azure Firewall. Now address prefix. Now what do you mean by address prefix? So you have to tell that route table that if a traffic is coming from this specific address prefix or this IP address, what should be the next hop? Okay, so if you want to allow each and every traffic originating from your Spoke VNet, so you want everything to be routed via your Azure Firewall, then in that case, you specify a traffic the address prefix of 0.0.0.0/0, which means anything and everything. Okay, so everything which is originating from this specific VNet should go via Azure Firewall. If you want to allow only specific traffic to flow from Azure Firewall, then you have to specify the exact IP address over here. So right now what I'm doing is I'm allowing everything from that spoke VNet. So in the route table, you have to also specify if this is happening, where the traffic should land. So what should be the next hop? So my next hop is my Azure Firewall. So in this
There is
case,
a
what I'm
question from my side that in the address prefix,
Mhm.
we have just put that 0.0.0, that's all the general traffic should pass. Okay,
Right?
can we use the subnet of that spoke network
Yes, we can
instead
do
of,
that. Yes,
so
we can do that.
that also will route the traffic, the complete traffic for that spoke network?
Yes, exactly. So, so only the traffic which is originating from those IP addresses will be routed via Azure Firewall. So let's say you are trying to access internet. Uh, so let me give you an example here. Let's go to our virtual networks over here. And since I'm creating for Southeast Asia, I'll go to the subnet. So my subnet range is 10.45.0.0. So if I specify over here 10.45.0.0/24. So what will happen? Any traffic which is originating from this address prefix will be only routed via Azure Firewall. And if you try to access, let's say google.com, that will directly go on internet and that won't go via your firewall. Getting my point? So if you try to access an internet services from this, that directly will go to your internet. That will not traverse from your Azure Firewall because those public IP addresses have not been listed in your UDRs.
Okay, okay.
Okay, so that's why in order to route each and every traffic, I am specifying 0.0.0.0/0. Okay, so there is no exception now. Every traffic that originates that has to go via Azure Firewall. Okay, now if this is the case, then I have to select the next hop. So what should be the next hop? Whether you want to redirect that traffic to your virtual network gateway or to a specific virtual network or to an internet or to a virtual appliance, or you don't really want to redirect this traffic and you want to terminate that traffic there itself. So in our case, since we have to route that traffic via this Azure Firewall that we have deployed in this hub VNet, we have to select the option as next hop type as your virtual appliance. And when you select this virtual appliance, it will ask you for the IP address. So here you have to specify the internal IP address, okay, because all this routing is happening internally. So we will require the private IP address of our Azure Firewall. So let's go to Azure Firewall and then copy the private IP address of this firewall and I'll add it here. So now what this rule means, any
Can we
traffic which
use
is
the public IP address for this firewall because that is bound to this firewall only? So if we, let's
so,
suppose if we just use the public IP address, right? So that is
so for
also
the
the IP.
So for the internal routing, we always use a private IP address since the traffic is not going over internet over here and your Azure firewall is sitting within your subnet. So there is no need to configure the public IP address of that firewall because these virtual networks are already connected with your hub VNet. So your UDR can easily speak with your Azure firewall or your virtual machines can easily speak with your firewall.
Okay.
And that's why we are supplying the private IP address of our Azure firewall. And I'll click on OK. And we have to do the similar configuration for our another route table, which we have created for Europe. So I'll go to route table Europe, go to routes and create a route. I would say here, what was the name that we had supplied to the route table Asia? Spoke VNet to Azure Firewall. So I'll copy the name and then I'll go to my Europe route table and do the same thing. Spoke VNet to Azure Firewall, and I'll also configure the same address prefix, and my next hop would be definitely my Azure Firewall. So the private IP address is this. And let's click on OK. Now, once you have created the routes, you have to also associate this route table with a subnet, because how would your route table come to know that the traffic is getting originated? Okay. So the next step is there are two ways of associating this route table. I'll show you the easiest one. You have to go to your virtual network and then click on your first virtual network, which is your CT VNet Asia, and go to subnets. So in this specific virtual network, I only have one subnet, which is a production subnet. You have to click on that subnet, and then you have something called as route table. Just click on this drop down and you would see that route table popping up here automatically. Let's click on save. Now that UDR has been associated with this route table. Okay. Let's go to CT VNet Europe, go to the subnet, and then associate my European UDR. So I'll click on save. Okay, so we are now done with all the networking components. So let's go and review this specific slide. So this is our hub virtual network, which we call it as CT VNet. Then we have CT VNet South Asia as a spoke VNet, and we have a CT VNet Europe as another spoke VNet. Okay, and then we have a connectivity setup between our CT VNet and CT VNet Asia via VNet peering, and same thing goes with the CT VNet and CT VNet Europe. Okay, now the connectivity has been established. We have also configured UDR at our spoke VNet 1 and UDR at our spoke VNet 2, so that the traffic which is originating from this specific VNet, I would say subnets, guys, not VNet, because if you have multiple subnets in a VNet, and if you have only associated your UDR with just one subnet, then only the traffic of that specific subnet will go via the Azure Firewall or whatever the configuration that you have done. So since we only had one subnet in both of these VNets, we are assuming that all the traffic from that VNet will now traverse via your Azure Firewall. Okay, even if you want to access internet, the traffic will be going via Azure Firewall, and if you have any specific rule applied here, let's say block internet, then that internet will not be allowed. Okay, so that is the beauty of your UDR, which is user defined route, where we are forcefully routing the traffic from a specific appliance. In our case, it's Azure Firewall. Okay, so let's now navigate to our Azure Firewall and start exploring different options. So I'll go to Firewall. Okay, and I have created this firewall. So let's click on this firewall. Now, a few of the things that you should be aware of. If you go to the rules section, because this is where we will spend majority of our time. So if you go to rules, and you can see the concepts that I have specified in one of my slides. So key concepts of Azure Firewall: NAT rules, network rules, and application rules. So in this example, you can see you have three different rules: NAT rule collection, network rule collection, and application rule collection. So NAT rules are typically used for translating the incoming traffic. Okay, that is called as a NAT rule. Then network rule is something which you create on basis of those 5 tuple rule, like source IP, source port, destination IP, destination port, and so on. And then the application rule, which controls the layer 7 traffic. So you can configure HTTP, HTTPS traffic, or traffic based on a specific FQDN like google.com or star.facebook.com and so on. So now, one thing which is very important with respect to Azure Firewall. Right now we have created an Azure Firewall, okay, and then we have not configured any specific rules inside of that. So right now my firewall rules are empty. And one of the thumb rule with Azure Firewall is if you have not explicitly defined any rules in your Azure Firewall, then the traffic which is coming to your Azure Firewall will by default be denied. Okay. Now, what I mean by that, let me show you this by a real-time demo. So I'll open my MSTSE. So what was those IP addresses? One was 31.4 and the other one was 10.45.0.4. So let me RDP to this virtual machine from my jump box. Because we have a VNet peering between those two VNets, we should be allowed to access this server. So 172.16.31.4. I'll enter my credential here. And then I am logged in to my virtual machine, which is in Spoke VNet 1. And let me also log into my another virtual machine, which is in Europe 10.45.0.4. Okay, perfect. So now what I have done is from this jump server, I have accessed both of this virtual machine which are sitting over here. Now let me show you something. Let's go to one of our virtual machines in Europe, and this is the virtual machine which is in Asia. So if I open a browser, let me close this server manager. And then let's open up an Internet Explorer over here. So I'll open Internet Explorer, typo. Let's try to access something like twitter.com. Okay. If you hit enter, you can see we are not able to reach twitter.com. Let's try to access google.com. And you can see it says HTTP request from 172.16.31.4 to google.com. Action deny, no rule match. What do you mean by no rule match means if you have not created any rules explicitly in your Azure firewall, that means that specific traffic will be denied by your Azure firewall. Okay. And the same thing will go with the other virtual machine. So if you go here, and why this behavior? Because we are routing all the traffic from this virtual machine via our Azure firewall. And that's why we are able to filter that traffic. So if you go to, again, a different virtual machine. So I'm right now in my Asian virtual machine, I believe. And here also I'll try to access google.com. And we should see the same behavior. It will say that HTTP request from so and so IP address action is denied. Now, what does that mean? This means that we are trying to access something from the Spoke virtual machines, the virtual machines which are in our Spoke VNet. And we have applied a UDR, which says that all the traffic which is originating from this subnet should go via Azure Firewall. And now the traffic is reaching to Azure Firewall. It is not finding any corresponding rule which says allow internet, because right now our Azure Firewall is created without any rules. And that's why if you don't have any rule in your Azure Firewall, then it is by default dropped. Okay, and that is what is happening in our case. So that's the first use case. Now, let's say I want to allow the traffic. I want to allow the traffic to flow to the internet. So which rule we should be creating? So since we have to allow traffic to the internet, we will be using, we can basically use network rule as well, or we can use application rules as well. So we can achieve this specific use case by either using a network rule or application rule. I'll show you both of them. So let's go to the network rule and I'll click on add network rule collection. So when you click on add network rule collection, you have to first supply the name of the rule. So I would say here, allow internet. And then here you have to provide the priority. So the difference in NSG and Azure Firewall's priority is NSG's priorities can be up to 4096 from 100 to 4096. But here you can create priorities from 100 to 65,000. So I'll create a priority with 1000. And what should be the action? So I want to allow something. So it will be allow. And here under the rules section, I will provide a name to my rule, say allow internet. And then since it is on layer 4, it operates at layer 4, you have to select the protocol. So internet is mostly about TCP and UDP. So I'll select TCP and UDP here. the source type. So whether you want to allow or deny traffic based on IP address or IP group. So I'll go with the IP address, and then the source IP address is. So in this case, I'll type in star because I want all the traffic from my virtual network which goes via this Azure firewall should be allowed. Okay. And the destination address is we don't know. Okay. So it will be again star. And what ports you want to allow. So what are those destination ports? So those destination ports are port 80 and port 443. So this is where your traffic goes on the internet. So the rule says allow internet. We have selected those two protocols, TCP and UDP. The source type is IP address and the source is star. We don't know any specific IP address, right? So we want to allow everything in our virtual network. And the destination address is also star. And what ports I want to allow? Only 80 and 443. So I'll click on add. Once this rule is created, what will happen? The traffic will originate from here, stating https://google.com. So when the traffic reaches to your Azure firewall, it will find a matching rule which says that allow port 80 and port 443. And that's where you will go on the internet. So let's wait for this rule to get created. Okay, so you can see a banner over here which says updating firewall. That's fine, but we should see the traffic now going to the internet. So I'm just refreshing the google.com. And we should be able to safely reach google.com. You can see the website is now opening up. If I try to access, let's say microsoft.com. There you go. We are now on the home page of microsoft.com. And the same thing goes with the other virtual machine. So if I try to access microsoft.com, we should be able to reach microsoft.com from here as well. So this was one of the examples of network rules wherein if you want to allow or deny traffic to a specific endpoint, we can do that. Now let me do one more thing. What I want to do is I want to allow internet for just one specific IP address. Okay, so over here, I just want to allow internet to this specific IP address and deny internet to all other IP addresses in my network. Okay, now what you want to do here is, as we have discussed in one of our presentation, one of our slides, that the Azure Firewall rule processing logic is evaluated based on the priority and the processing rules. Okay, so where you have applied this rule. So we are currently dealing with the network rule, and now our requirement is we should be allowing internet to go. So only one specific IP address should be able to access internet, and the rest of the IP address should be blocked for the internet. And we have also said that lower the priority, higher the precedence. So one with the lower priority will have higher precedence, and higher priority will have a lower precedence. So what I want to do is I'll create one more rule now in the network rule, which will have a priority less than what we have created, which will deny internet for that specific IP address. Okay, so now I'll click on add network rule collection, and here I will say deny internet for Asia VM. So this is the name of the rule, guys. It could be anything, and the priority is 500, which is less than what we have ruled, and the action should be deny. So I'm saying deny Asia VM to internet. So here I will specify the protocol. It means TCP and UDP, and the source type is IP address. But here in the source, since I want to only deny this traffic for a specific IP address, I'll just type in the name, the IP address. Okay, so 172.16.31.4. So 172.16.31.4 is my source IP address, and the destination IP addresses I want to block access to all the IP addresses on port 80 and port 443. Okay, now if I click on add, we have two different rules, and we have these rules which are basically contradicting each other. Now what will happen if let's wait for this rule to get created. So the one which lowest priority says that deny internet, let me open this rule, deny internet only for this IP address. Okay. And I have another rule which says allow internet for all the IP addresses. Okay. So in this case, what will happen? The first rule will be evaluated, and there the internet would be denied. And then the other rule will allow internet to the rest of the IP addresses. So let's see the behavior here. So I am on the same virtual machine, which is 172.16.31.4. And here I'll try to access google.com. And it's taking some time. And there you go. You can see the behavior. It says this page can't be displayed. Okay, let's try to open another tab and try to access Microsoft.com. And if it's taking so much of time, I can assume that it is not opening. So here it says this page cannot be displayed. Now let's try with other virtual machine where we have allowed the internet. Okay, so if I try to access google.com or let's say facebook.com, no. Facebook.com, you can see I should be able to reach Facebook.com. So what has happened in this network rule is we have created a rule with lowest priority to deny internet for a specific VM. And then we have another rule with the highest priority, which will allow internet for all the virtual machines in the network. Okay, so this is one of the examples of network rule collection. Now, the other thing that I want to show here is, so let me see what is the IP address of my hub VM. Okay, so this is a virtual machine which is acting as a jump box now, and this is the IP address. So let me copy this IP address and go to my spoke VMs and open a command prompt and see if I can ping those IP addresses. So it's pinging because we have a connectivity. And if I go to this specific virtual machine, and if I ping this IP address, I'm able to reach that IP address. Now my use case is I want to block ICMP. So no one should be able to ping anything in my network. So what I'll do is I'll go to the network rule collection. I'll click on add network rule. Let's say deny ICMP. So if you want to deny, if you want to block ping, then we use ICMP. Okay. So priority, let's say 1100 is the priority that I'm going with. Action is deny. So here we'll create a rule, deny ICMP. So in the protocol, you have a specific category called as ICMP to block the ping. So you can click on ICMP. The source port is, so source type is star, destination is star. And now this is a glitch, guys, in Microsoft Azure Firewall's rule that if you're allowing or denying ICMP, ICMP does not rely on any port. So just like your other protocols like HTTP, HTTPS, they have the specific ports, like HTTP has port 80, HTTP has 443. Similarly, ICMP does not have any port. Okay, but let's make it star. And what we are doing is we are denying ICMP. So let's click on add and wait for this rule to get added. And the way I am demonstrating you, this is how the rules are actually created in your production environment based on the use case or based on the requirement. Let's refresh. Okay, that rule has been created. And now let's go to our spoke VMs and try to ping. Okay, it's still pinging. That means the rule has not taken effect. Let's wait. Let me apply a star -T. And here also, let me apply this -T. Let me just validate this rule once again if I am correctly applied. So deny ICP, ICMP, protocol is ICMP star star, and the destination port is also star. So ideally it should deny. It should not take so much of time. If it is not denying, that means we have created a wrong rule, I believe, but I don't see any problem in this rule. Deny ICMP, the priority is 100. The action is deny. Then deny ICMP, ICMP. No, star destination addresses. Maybe we can revisit this specific rule, but for now, let's keep this rule as it is and move on to another rule. Okay. So right now, what we have done is, so let me remove this specific rule of denying internet, because you might have now an idea how we can deny on a specific VM or a specific range of IP addresses and allow on the other. Okay. So let me go to this rule now and delete this deny internet rule. And let me also delete my allow internet rule as well, because I have agreed that I'll show you two different ways of allowing and denying internet. One is via the network rule and the other one is via application rule. And if you look at this Azure Firewall, for a person who doesn't know the concepts of firewall, he may find it difficult to configure rules at the initial stage. But once he's used to the terminologies like source IP, source port, destinations, and so on, then he can easily create rules based on a business requirement. So I'll also delete this allow internet rule. Meanwhile, if you guys have any questions, just let me know and I can take those.
Sir, suppose we have more than two subnets in Asian VNet. So can we associate the same UDR to that subnets to all that subnets?
Yes, you can do that. You can very well do that.
Okay, so no need to create the different route table, right?
No, not required. So you can associate one route table with multiple subnets. That is completely doable. And that is a valid question, because if you have a virtual network with multiple subnets and you have virtual machines in every subnet and you want to ensure that the routing of traffic is happening via Azure Firewall so that you can take benefit of centralized rules, yes, then you can associate one UDR with multiple subnets. Any questions, guys, on the network rules that we have created so far? On first, we allowed internet on all the for the entire network. Then we denied internet for one specific virtual machine with the source IP address as the virtual machine IP address. And then the third rule that we created for the ICMP, which didn't work, we can revisit this rule at the end of the session. Okay, so now there are no internet rules. If you go to the internet, if you go to that virtual machine, you won't find internet to be working. Okay, so let me minimize this. And if I open up my Internet Explorer, and if I try to access google.com, I should not be reaching internet because there is no explicit rule created in your Azure Firewall to allow internet. Now let me show you how you can do this via application rule. Okay, so I'll click on add application rule collection. And here in the name, I would say allow internet. Okay, and the rule and the priority, let's go with the 1000 priority, and I want to allow. So once you have done this, under the target FQDNs, okay, so there are two different sections in application rules. One is the FQDN tags, and the other one is the target FQDN. So the one which we are interested at this moment is target FQDN. I'll tell you what this FQDN tags are, but let's focus on target FQDN. So I want to basically allow internet, right? So I'll type in the name of the rule, allow internet. So source IP would be any. Now with where you want this IP to be allowed. So I want to allow this IP on the port on HTTP protocol and HTTPS. And what target FQDN? So if you have a specific requirement of only allowing Microsoft.com in your network, you can use the wildcard as well, which is Microsoft.com. Microsoft.com. And now in this case, what will happen? Only Microsoft.com will work and rest of the websites will not open in your environment. So if you want to let all the other websites to be open, you can just specify star and just click on add. So we have now created an application rule which will allow internet on all the virtual machines that are traversing via your Azure Firewall. Okay, so let's click on refresh. All right, now if I go to my virtual machine, I should be able to reach google.com. Okay, Microsoft.com, and you can see the web page is now opened. Let me go to my other virtual machine in my other spoke VNet, and let's hit Microsoft.com here as well. So you can see I'm able to open Microsoft, or I can open any website on the internet. So if it's facebook.com, if it's, let's say, twitter.com. Okay. All right. Now I have one use case, and that use case is, and you might have seen this use case in a lot of organizations wherein internet is allowed, but what organization does is they typically block specific websites like your social networking websites, or there are some other specific categories which these are not allowed in an organization. Okay, so if you have the similar use case wherein you want to deny access to specific websites, even that can be done. Okay, but when you define a rule, you have to be very cautious in terms of the priority, because the rules are evaluated on Azure Firewall based on the priority. Okay, so you already have 1,000 priority rule, which is allowing internet to all the virtual machines in the network, and there is no exclusion to any website. So let's create one rule which will be of high priority. That means less than this priority. So I'll say something like deny internet to specific URL, and I want to create this rule with high priority, so it will be 500 less than 1,000, and action I want to deny. Okay, and now in the target FQDN, I would say deny social networking, and the source IP address is star. My protocol is HTTP and HTTPS, and in the target FQDN, let's say I want to block star.facebook.com, and you can enter comma separated values here. So star.twitter.com, and let's say star.instagram.com. And let's click on add now. So now we have created two different rules. One, the first rule with highest priority says that deny internet to the specific URL, or deny access to the specific URL. And then the other rule with 1,000 priority says that allow internet to all the URLs. So in this, what will happen? The internet will be blocked to the specific websites that we have specified in this rule, and rest of the internet will be allowed via this rule. So let's check this out. So we will try to access facebook.com. And when you hit facebook.com, it says this page can't be displayed. Let's try to access twitter.com. And the same thing over here as well. Let's go to instagram.com. Okay. And Instagram also says the same thing. Okay. And you can see the rule is also specified in this here. deny social networking is a rule that is denying internet to this URL. But let's try to access google.com. There you go. Google.com is allowed here. If you try to access, let's say github.com, github.com, and there you go. You can also access github.com. Let's try the same thing on the other virtual machine. And let's try to access facebook.com. So this behavior will be throughout your network. Okay. Twitter.com. And let's try to access google.com, one of our favorite websites. There you go. So this was one of the examples of application rule, wherein if you want to control your application layer traffic, you can create application rules. Okay. So we saw the network rules as well. And we also saw what are application rules. Though I have a couple of use cases in the network rule collection. We'll take these use cases after we have completed NAT rule. Okay. So what is a NAT rule? In our presentation, we have discussed that NAT rules are used to translate your incoming traffic to a specific IP and specific port. Okay. And that's what my use case right now is. So if you look at the virtual machines, if you look at the spoke VMs, which are in Southeast Asia and West Europe, these virtual machines do not have any public IP address. So I cannot reach this virtual machine with this private IP address from my local machine. Okay. So if I do okay, let's go 10.45.0.4. If I hit connect, I won't be able to connect because I don't have any networking connectivity set up with my laptop and my virtual network. So if you want to do that, you can do that via your point to site connection, or you can also have a site to site connection. But I don't have either of this. So the only way I can reach to this virtual machine is via public IP address, which I don't have, or else I will have to log into this jump box to access this VM, which I'm already doing that. Okay. But I want to specifically give an example of NAT rule. So what is a NAT rule? So if you want to access this virtual machine over internet, we can take advantage of the NAT rule. And what NAT rule will do is it will basically translate the traffic which is coming from the internet to an internal IP address and a port. Now let's see how that goes. So I'll click on add NAT rule collection. But before that, since the traffic is coming from the internet, the traffic will land up on the public endpoint of our Azure firewall. Okay, so I'll first go to my overview and copy the public IP address of my firewall appliance, which is Azure Firewall. So I'll copy this in one of my notepad and I'll go to my rules. And under NAT rule, I'll click on add NAT rule collection. And here I would say allow external RDP to Asia VM. Okay. What is the priority? So everywhere you have priority. So let's make it as 1000 priority. And now I have to create a rule. So I want to create a rule. Let's say allow RDP. What is the protocol on which is being used by your RDP? So it is mostly TCP, but we will go with TCP and UDP as both. So do you know from what IP address your connection is going to come? So if you don't know, then you can simply put it at star. And then it is asking us where does the traffic should land. So the traffic should land on our firewall because that's where our landing zone is. So I'll copy this firewall's IP address and I'll paste it over here in the destination IP address. OK, and you have something called as destination port. So on what port you want this traffic to land on the firewall. So since RDP is very sensitive port, I want the traffic should come from a port 40,000. If someone wants to access my Asia VM, they should use a combination of this public IP address colon 40,000. OK, so until destination port is fine, but where that traffic should be translated to. So that traffic should translate to my private IP address of my Asia VM, which is this. So it's 10.45.0.4, 10.45.0.4, and to which port this traffic should be translated. So it should be translated to my RDP port, which is 3389. Okay, so we are now creating a NAT rule which will translate the traffic coming from internet. So source is star, that means anything. The traffic will land up on my firewall. This is the Azure Firewall's public IP address. And when it lands up on firewall, it should land up on port 40,000. And once the traffic lands up on my firewall's port 40,000, that traffic will get translated to the internal IP address of my VM, which is 10.45.0.4 on port 3389. Okay, let's click on add and see if we are able to access that virtual machine from the internet. Okay, I'm just waiting for this rule to get updated. And there you go. The rule has been now updated. What I need to do now is I need to copy this public IP address. And if I go to my MSTSC and just type in the public IP address and hit connect, it won't allow me to access that virtual machine, because the way we have set up this rule is we have said that the traffic should come from internet on port 40,000 so that it can be translated to my internal 3389. So there's the error. So I'll follow as an apply colon and type in the port number, which is 40,000. If you hit connect, under the hood, you can see it has now translated. So it took that time to translate the traffic to the internal private IP address. And now if I type in my password, I should be allowed to access this virtual machine. You can see I'm connecting to the virtual machine, which is in Southeast Asia. So click on yes. And then I will be allowed to access that virtual machine. So this is called as DNAT, which we also call as destination NAT. You can see here, I'm logged in now. If I want to access, let's say facebook.com, I can access. Oh, so we have that rule in place, right? Which will deny Facebook. So let's create a similar rule for our European virtual machine. So I'll go to DNAT rule and I'll create one more rule called as allow external RDP to Europe VM. Okay, and this will be again priority of let's say 1500. And here I'll say allow RDP to Europe VM. The protocol will be, I'll select both for safer side. And now I'll show you one more example. So let's allow traffic to this specific virtual machine via a specific public IP address. Okay, so I want, let me go to my hub jump box. So this is my jump box. You can see here, if I type in host name, it should be CTDC1. So CTDC1 is my jump box. Now I want to only allow RDP traffic to that specific VM from the public IP address of this VM. So if I go to google.com, let's first, okay, so this is the public IP address. So I want to allow traffic to this virtual machine only with this public IP address 52.247.127.49. So let's 52.247, I believe 247.127.147.29. Is that the IP address? So 52.247.127.49. 127.49. Okay. So I want to only allow traffic coming from this public IP address to be translated to this internal. So the destination IP address is again firewall. So let's copy this firewall, and I want this traffic to come on port, let's say 40,001. And where it should translate to my Europe VM. So let me go to my Europe VM here. Copy this IP address, paste it here, and on what port you would like to translate. So I want to translate this to 3389. So let's click on add. And now what I'll show you is, let's go to that virtual machine. So I'll copy this IP address, go to this virtual machine, and let me open up my MSTSC client. I'll specify my port as well. So 40,001. And if I hit connect, it is initiating a remote connection. And let's see whether it allows us. No, it's not allowing us. 40,001. Let's do a connect once again. Let's see what is this rule exactly. 50 to 40,001, which should translate to 3389. So 52 to 47, 52 to 47, 127, 49. It should ideally translate. Let's test with something else. So let's make it star over here and see if it allows RDP. What is happening? Okay, let's see how it goes. Because the problem with the public IP addresses of Azure resources are they are already NATed. Okay, so we don't know under the hood which port is being used for performing this NATing. So that's why I'm just changing the source IP address to star to see if we can access this from anywhere. So let's go to run MSTSC, public IP address of my firewall and the port number 40,001. 40,001. Hit connect. Yes, I can reach from my local machine. Let's do the same thing now from this machine. Let's try to connect. So yes, we are able to reach. So let's see if we can allow only RDP to my service provider's public IP address. So what is my IP? So if I go to my IP address, this is the one. So I'll copy this IP address and allow it in my firewall. So allow external RDP to Europe VM. And then instead of this source as star, I'll specify the IP address of my service provider. Let's click on save. Let's wait for this firewall rule to get updated. We can give it a shot. So let's open run MSTSC. We are trying to connect to our firewall, which is 22. Let's copy this. Let's put it here, colon 40,001. When I hit connect, you can see I'm able to reach to that Azure virtual machine. And now let's go to one of our Azure virtual machines, which is the hub VM. And let's try to connect from here as well. So if you try to connect, you can see it is not allowing the connection to go on this specific port because we have only allowed RDP to that European VM from this specific public IP address. So this is working for my public IP address. And guys, as I said, Azure virtual machines IP addresses are already NATed. So we don't know under the hood what port is being used. Okay. So, but if I try to access from my local machine where I have allowed access, it should allow me to log into my Europe VM. Let's hit OK. And there you go. You can connect to your West Europe virtual machine. And there you go. This is where we are now. All right, guys, any questions? So I have covered almost all these three different rules: NAT rule, network rule, application rule. The only thing that is left is the threat intelligence that we spoke when we were going through those slides. That Azure Firewall also comes with the threat intelligence. And these are the threat intel mode. What you mean by threat intelligence mode is you can set this to off if you don't want this. But there are two different modes, which is alert only and alert and deny. What do you mean by alert only? Alert only means, let's say if Azure has its own intelligence engine, and in that intelligence engine, what Microsoft does is it continuously keep on updating that intelligence engine and keeps on tracking what are those blacklisted IP addresses on internet, those blacklisted FQDNs, domains, and so on. So if a traffic is coming from that specific IP address to your firewall, it will allow that traffic. But what it will do is at the same time, it will create an alert as well. Okay. And if you don't want the traffic from this blacklisted IP addresses from that Microsoft Intelligence Engine database, you can select alert and deny. If you set this intelligence mode to alert and deny, what it will do is if Microsoft suspects that the traffic is coming from one of the blocked IP addresses in its databases, then it will alert the customer as well as it will deny that connection. So it will not allow that connection to go through our firewall. So this is the intelligence, threat intelligence that is integrated with Azure Firewall. Okay, so that was about threat intelligence. And the last thing that I want to tell you about the Azure Firewall is each and every traffic that is flowing from our Azure Firewall can be tracked, can be audited. Okay, so if you are aware of log analytics workspace, we can send this diagnostic sending. So we can send this diagnostic information to our log analytics workspace. So if you go to diagnostic settings and if you click and add the diagnostic settings, you can send this information to your log analytics workspace where all this information will be stored in your workspace and you can query this information using Gusto query. Okay, so this is one thing which you can additionally do to ensure that the traffic is being recorded in the system and you can view this traffic based on the data that you have collected. Okay, so let's go back to rules section. Any questions, guys, for me on the NAT rule, network rule, and application rule?
No questions from my end.
No questions, sir.
How
No
about
question.
Shant? About Akhil? Okay, so guys, this was about the Azure Firewall. Okay, and I hope that the session was meaningful and you will be making your hands dirty soon on Azure Firewall. And if there are any questions, you can let me know over email, over phone as well. Okay. If there are any specific questions around this Azure Firewall, I can take those questions before we go ahead and conclude our today's call.
No questions, sir.
Okay. So I'll assume this silence as no, and also confirm that we are good to close this session. Okay, so finally, thank you very much for joining this session, guys. I hope this session was helpful and you'll take benefit of this session by setting up your own Azure Firewall instance in your Azure subscription and play around with this different rules like NAT rules, network rules, and application rules. Thank you guys for attending today's session. Have a great day or great night, I would say, ahead. Okay, thank you very much.
Thank you.
Thank you, sir.